Hello friends, today we will discuss q root 2, root 3 is a simple extension of q. This means is that we will prove that firstly we know that q is a field, and second we prove that if we extend it q root 2, root 3, okay, then we show that it is a extension. Not only extension, it is a simple extension. For simple extension, what is the difference between simple extension and algebraic extension? Algebraic extension is that there exists a polynomial of type x square minus 2 and x square minus 3. Then the roots are in this field, so this is the extension from q to q root 2 root 3. So this is the algebraic extension. But when we say that it is a simple extension, we need to prove that there exists only one element this type, q alpha type. This is an alpha root 2 plus root 3 type. After adding this, it is equals this and this, both different types of polynomials roots existing in the field, and which is equals to single element, only adding single element to the field, then it is called simple extension. Simple extension means there exists algebraic extension. This means that root 2 and root 3, two other types of roots, different types of roots, but we say that simple when only one element gives the extension, only one element gives the extension, then it is called simple extension. How do we prove that q root 2 root 3 is equals to q root 2 plus root 3? It is a very simple proof that firstly we will take alpha, firstly we will take it contained in this and this contained in this, then it is equals, right? We will show only that type of thing. We show that alpha is equals to root 2 plus root 3 is a primitive element by showing root 2 is in q alpha. Q alpha is that root 2 plus root 3, right? Root 2 is in q alpha and root 3 is in also q alpha. Then it will implies that q root 2 root 3 is contained in q of alpha type field. Now we prove that the field generated by the sum, this field is generated by the sum equals the field generated by the individual. So we will then say that the containment is other side is also true, then we have proof this is a simple extension. Now let us prove that. Firstly we show that q root 2 plus root 3 is contained in q root 2 root 3. As we know that root 2 is in q root 2 root 3, right? It is in root 2 and root 3 is also is in this, right? So if it is a field extension, then the sum of this is also is in this, right? If the sum is also is in this element is in q root 2 root 3, so this implies that q root 2 plus root 3 is contained in q root 2 root 3, right? Now second, what we have to prove that q root 2 root 3 is contained in q root 2 plus root 3 is other side of this, right? So how do we prove that? As it is a single element and it is different roots, so let me take what we have. Firstly take this type of thing, alpha. We have alpha, we need to show that root 2 and root 3 in terms of alpha only, right? If we prove that these are the terms which are in terms of alpha, so it is proved that, right? Now let us take alpha square. Taking alpha square, this will give this, and this implies that 2 root 6 is equals to alpha square minus 5. So this implies that root 6 is in q alpha, right? If root 6 is in q alpha, then it is alpha dot root 6. Now alpha dot root 6, what is alpha dot root 6? Root 3 plus root 3 root 6. This is implies 2 root 3 plus 3 root 2. This system has linear system equation. First is 2 root as we know that alpha, and second is alpha root 6, right? After solving this, we will get root 2. After solving this, we will get root 2 is equals to alpha root 6 minus 2 alpha. So this implies that as alpha is in q alpha and root 6 is also is in q alpha, root 6 is also is in q alpha, So this implies that root 2 is also is in Q alpha. If so this is true. If root 2 is in Q alpha, then it is implies that root 3 is equals to, we will write up as we know that root 2 plus root 3 is equals to alpha, right? So if root 2 is in Q alpha, this field, then root 3 is equals to, we'll write up alpha minus root 2. This is also in Q alpha. So this will generate the field simple extension Q root 2 comma root 3 is contained in Q root 2 plus root 3, right? So this will implies that this is a simple generation as containment is equals. The extension is simple. The polynomial is this: px is equals to x to power 4 minus 10x square plus 1 over q for this root.